For this transfer function, we have one value of k, 3, 0 and 4 both. The value of k is 200. D is code to find gain margin, phase margin, gain crossover frequency and phase crossover frequency. D is both plot for amplitude response. This is both plot for phase response. The value of phase margin is 92.87 and the value of gain crossover frequency is 31.79.
The phase margin for the transfer function is 92.87 degree. Gain crossover frequency is 31.79 radian per second. Regarding question, we need to improve the phase margin of the system by 10% using a lead compensator. To get a new desired phase margin, the current phase margin is 92.87 at with a new value current phase margin that is 10% higher. The value of a desired phase margin is 102.157 degree. Next, safety margin for lead is 15. To find the phase max, PM required is 102.157 degree minus with PM current which is 92.87 degrees and add with a safety margin. The value of phase max is 24 degree. Using a phase max value, we can solve for alpha. The formula is phase max is equal to sine inverse alpha minus 1 over alpha plus 1. And the value alpha is 2.373. Using alpha value, we substitute into gain crossover frequency, omega m, and solve for torque. The formula of omega m is omega m equal to 1 over torque multiplied by square root of a. The value of torque is 0.02. Then we rewrite the lead network transfer function in the form of GC is equal to 1 plus alpha multiplied by torque S over 1 plus torque S. Then GC is equal to 1 plus 0.047 S over 1 plus 0.02 S. This is the Skylab code for lead compensator. Regarding the lead network transfer function, the numerator is 1 plus 0.047 S and denominator is 1 plus 0.02 S. This is the board plot lead compensator for amplitude response. This is the board plot lead compensator for phase response. Overall system phase margin is 94.72 degree. This is satisfying the requirement for phase margin must greater and equal to 92.87 degree.
From the board plot, the current phase margin is 92.87 degree. Since the question asks to improve 10% of the phase margin of the response, we need to calculate the new desired phase margin. The new phase margin can be calculated by adding current phase margin plus 10% of current phase margin plus safety margin. Therefore, for the desired new phase margin, we can get 107.57 degree. Next, we need to find the frequency. Before we find the frequency, we need to calculate the phase first. For the phase, we need to add negative 108 plus 107.57. Therefore, we can get negative 72.43 degree. By using Skylab, at phase negative 72.43 degree, the frequency is 31.59 radian per second. Next, we find gain at the new GCF. From the board plot, our new gain is 50.62 dB. Then, we put 0.1 decade below. For the Z, we can get 3.159. From the Z, we can find tau. Tau is 0.3168. Then we can rewrite the phase-led network transfer function. By using the information in the phase-led network transfer function, We write the code in the skylight. By simulating the skylight, this is the graph for the amplitude response. This is the graph for the phase response. The new phase margin for the LED compensator is 102.74 and the new gain crossover frequency is 5.06. The compensator can be used to achieve 10% improvement of phase margin is LED compensator. This is both plot for lead compensator and LED compensator. To determine which compensator can achieve a 10% improvement in phase margin, we need to compare the change in phase margin for both the lead and lag compensator. Let's calculate the improvement percentage for both compensator. For lead compensator, we get 2%, and for lag compensator, we get 10.64%. Based on the calculation, the lag compensator can achieve a 10.64% improvement in phase margin, while the lead compensator only provide a 2% improvement. Therefore, the lag compensator is the one that can be used to achieve a 10% improvement in phase margin. The lag compensator introduce additional phase lag which help stabilize the system and increase the phase margin. In this case, the new phase margin of 102.7499 represent a significant improvement compared to the current phase margin of 92.865984, meeting the desired 10% improvement criteria.